I've been offering here. And as we say, from now on, the screen is yours.
Thank you very much, Seb. I think your presentation is more than, let's say, appropriate and extensive, so I won't add much to that. Thanks to everybody online. Good morning, good afternoon, wherever you are. So it's a pleasure for me to be here today. I think I'm going to keep the camera on just for a couple of seconds so we can say hi and you can see who's speaking behind the voice. And after that, I will not use it to save a bit of the bandwidth for the presentation. So it's a pleasure for me to be here today, and as Seb has mentioned, the title is a bit ambitious, but it does capture a couple of the keywords which are very common now in our sector, but also in academia and industry in general. So I'm going to discuss data science and predictive analytics a bit, and I'm going to do it as applied to large-scale phenomena. So the first part of the presentation is going to be about the team, the emergent team, which is obviously related to big data. And the second part of the presentation is going to focus on one specific domain, which I've chosen to be tourism. We're doing some very large-scale trials, which are rooted around the activities that we do at the University of Salzburg on collective sensing. And I'd like to show you some results which have been published very recently. You can find some of this material at the website, which is on screen here, collectivesensing.org, which is basically the place where we put the research and development work of our team in Salzburg. With this, I'll go back into voice only, and I'll go and talk on the slides. So hopefully you see it properly. The reason why we're interested in this topic has to do with the emergence of a certain number of data streams and the proliferation of data, which is largely associated to these 5 themes. The first one is that almost everything that we do in business and personal life now, it is mediated by some form of machine, which captures our activities into digital transactions. The side effect of that is that almost everything which is done in industry, in transportation, or by humans, it is recorded as a sort of digital trace. At the same time, we got used to publish information about what we like, what we do, where we go and everything and like that through social media, which is another big stream of data. The Internet of People is what we have been using for several years, but aside from that, we are starting also to see objects which are connected to the cloud and to the Internet. And eventually these objects will be many more than humans are, and they will all create data. And finally, you also have data which has been generated over time by particular governments, but not only governments, which before was stored and was not accessible. Now it becomes open. So all these things together essentially produce an unprecedented amount of data, which many organizations and individuals believe stores a lot of information, can be valuable for research, for business, for medicine and everything. If you want to just get a perception of that phenomenon, I think this picture and the next one illustrate it in a simple but effective way. This is people waiting for the new Pope in 2005, 2013. It's the same place, it's the same setting, it's exactly the same reason why they're there, and the difference is represented by the way people capture that information and react to that event. You can see at the bottom a very good representation of what big data is. It's primarily data that comes bottom up, it's not organized by anybody, it's just people generated. There's a lot of duplication in this data. Essentially everybody in this image captured the same image, but also means that once this picture is stored somewhere, it basically declares that the person that has stored it in Picasso or whatever the system was there, was interested in this event. So there is something that can be used by somebody later on to generate some evidence, information, some intelligence around that. So we have this tendency of generating lots of data, but of course this is associated with the fact that it costs almost nothing to store data now. 2005, 2014, about the same time span, and this is the same card which stored 128 megabytes and now 128 gigabytes. So you have the reason why people do these kind of things and the fact that it costs nothing. So the entire phenomena overall has double-digit growth, and that's the creation and proliferation of digital data in any type of form and format, which by the economists has been estimated in total to be about 0.13 zettabytes in 2005. Zettabytes is lots of zeros. And to grow into 35 zettabytes in 2020. Now, it doesn't really matter what the zettabyte is, but this diagram shows that there is a phenomenon which has a double-digit growth sustained over 15 years. And by the way, there's no reason to believe that this is going to stop there. Now, there are not too many things which grow at double-digit for this long. Therefore, when you see something like this, you know, it's reasonable to pay attention to it. And by the way, it also shows another of the challenges or difficulties which are related to big data, is that one of the few assets that we come across, data in particular, which has the characteristic of it being abundant instead of scarce. We are very used to dealing with scarce resources. We are not really good at dealing with abundant resources. And this is the case of data. But let me see first, beyond definitions, what we mean with big data. So we are generating data. There's good reason for doing that. There are many sectors where this happens. But what do we actually mean? What's the difference between data and big data? Well, let's do it through an example which is based on personal transaction purchases. It's just one of the many examples we can make, but this probably is the simplest. If you buy a book, this event doesn't tell us or you or the shopper anything about you. It is just that you make one transaction, it's one data point. If for any reason all additional transactions are also recorded, then your purchasing pattern is disclosed. Therefore, you might disclose, for instance, you buy a certain type of food only on Wednesday or only on Fridays, and there's a certain pattern behind. If all the transactions, not only mine, are recorded, but also those of others, then patterns can be analyzed and contrasted with the patterns of others. And this actually places my behavior in a wider picture, which leads to segmentation, which is basically what happens when you buy a book at Amazon and they suggest what else you could buy based on what other people in Amazon have done. Finally, if you add other types of data like location, demographics, online activity, and so on, then you have a much richer profile that can be used to provide recommendations, but also predict behavior. For instance, detect fraud. It happens to me since I travel a lot that my credit card is blocked frequently because my purchase pattern hits a number of algorithms which believe that I should not do what I'm doing because of the place where I am, the frequency of my transactions, and what I buy, and so on. That's actually what happens in the last one. So from the first to the last, you have basically the distinction between data and big data. So this is not a definition, but I think it is a more useful characterization of what big data is. What changes in the meantime is, of course, quantity, variety, and velocity of data, but also the need to start using different methods in data management. Traditional databases, for instance, tend to become ineffective and inefficient in dealing with all these amounts of data. And you have new tools, you might have heard of Hadoop and all these kind of things, which to a large extent break down the process in small pieces, they run them in parallel and compile at the end. So they have been designed to deal with massive amounts of data. You have a variety of new suppliers that are becoming central to the ecosystem. So it's not only the traditional data players, but the new ones. If you want to ask somebody about your future health, the ones that know more are not your doctors, but probably are your grocery store, the organization that sell you food. They're in much better position to predict your future health, and they might well do that as we go forward. And finally, in all this, the relationship with customers, products, and data owners need to be redesigned. From this example, you have a clear view about the sensitivity of all this. And finally, and that's the reason why we do these seminars and why we have these courses, why we develop this kind of education programs is because the skills and knowledge to deal with this are reasonably different from the ones that we have created in the last few years. If you look from a data point of view, there is a change also in the terms, in the type of data sources which you see in the landscape. There are new ones, which is primarily to the right-hand side, top side, type of data sources. But the mechanism and the message of this slide here is that new data providers tend to dominate in terms of quantity and frequently also quality the new data landscape. And one, of course, a reasonable question here, but does this all make a difference? Now, there are several examples where this actually made a difference, and I picked two before we go into our tourism and large-scale human phenomenon. This is 2011, and this is a contest in the United States. This is a program called Jeopardy. It's a quiz show, and the presenter asks the participants here fairly complicated questions about general knowledge, and the fastest that responds wins a money prize. A machine called Watson, is an IBM machine, decided to challenge these two guys, which are the historical champions of Jeopardy. And they did it in 2011. It won by, I think it was the total prize that the machine won, something like 5 times the closest one of these two. So a machine that wins at answering questions which are formulated in a way which is typically associated to the ability of humans to interpret language. Now, the interesting thing here is that Watson doesn't know what the question means. It doesn't even know what the answer means. But had figured out an algorithm to put together question and answers in such a way that they fit in terms of data. So it doesn't have to interpret what the meaning of question and answer. It simply finds the best fitness from all the candidate answers that it can find is in a certain number of data sets. And that associates that and answers. And it seems to work. So to a large extent, Watson is a data machine rather than an artificial intelligence machine. Well, of course, we can debate if there is any difference in these two. The other one, which is always used as an example of how data, the new data, can make a difference, it is the Obama campaign. So I have some colleagues which have been inside a campaign. They worked in 2012 in particular to help the Democrats, the campaign of Democrats, through a data team. And I'd like to show you two things. The first one is what we, outside of that group, could see from the newspaper. These are the polls, the results of the usual political, the usual attempt to measure political preferences. And they were published across, from June to November. And you can see here the huge variation, the huge, let's say, unpredictability of the race, which we all perceived, read about in newspapers, watched on TV, and so on. Until the last minute, it was really unclear whether Romney or Obama were, which of the two was going to be the winner. So this is what we saw. This is what the data team, people that held the campaign, actually modeled going forward. They used all type of data they could put their hands on. They created a model of 250 million Americans, and for each American, they really estimated the probability was going to vote one way or the other, probability they could be influenced by the campaign, and so on. By updating this model daily with all the information you could get from the field, they essentially created not a sample, but a model of the coalition of Americans that were going to vote. And because of that advantage, they could estimate much, much better the result of the election, which is this. So on top, you can see what the data team of the campaign could estimate. And the red one is the poll, so you can see how close it was to the end results. So there are a number of things here that are worth underlying, but the first one is that you have machines now that are capable enough, based on data, to answer very complex tasks, and you also have examples where this makes a big difference. And there are many, many others. I'm not going to read here the entire slide, but you have different uses of data to predict a variety of things. Nokia, for instance, predicts the location of mobile phones for the next day. Target, which is a large retailer in the US, has algorithms to predict pregnancy status simply by looking at it. There are judges and parole boards in the US that actually consult predictive models before deciding who stays in prison and who's released for parole. HP uses data to predict which employee has the highest chance of quitting and take measures, and so on and so on and so on. There are many, many hundreds of these examples, which, on the one hand, you will find them interesting. Some of these are, sometimes exciting, sometimes they're even concerning, scary. But this is what can be done with the new data and the new techniques. Switch gear here and show you one domain of application which we explored in the last year. We use data from telecom operators and from social media, and we try to look at in what way this data and the new tools could be used to model and understand tourism in particular as a large-scale phenomenon. We've done it in Italy, and I wished I could have a better scientific reason for choosing Italy, but in practice the only one is that I'm Italian and I like to do it there. So could it be done anywhere? But we use Italy as a case study. So we have 1 year of data, Twitter and telecom data, and we looked at tourism. Essentially all the tourists in Italy. Let me show you one slide. By the way, this is far from, because if you can see in Italy, you can, in a very small number of, let's say, if you look at inside the country. From this data and from this model, you can basically look at any nationality, any period of time. It doesn't really matter. And you can also, and you see this depth is where both are together. It's harder to see because this is basically the raw data represented. But it gives you perception of the ability of, through this kind of models, to go from the national scale to the globes, to the local scale, or can be down to the street scale, if you want. It's interesting then to start narrowing down in terms of segments. For instance, a simple way of segmenting is to look at how many destinations the tourists visit in Italy. The Chinese, for instance, tend to visit one city, majority of them, but also many of them visit 2 and 3 cities, which is normal because, you know, once they come to Italy, they travel in a few places. Germany is close by, and they tend to visit one place. So once they come to Italy, they go to Venice, to Milan. Maybe they come back because they visit more frequently, but it's one place. What also happens is that if you see the Chinese, they tend to revolve in a sort of star centered on Florence, and then they go to Venice, they go to Milan, they go to Rome, but the center is Florence. The Germans, they tend to revolve around Verona and Venice when they come for one day, or go to the south when they go for more days. So that's to say that you have the capability of segmenting very specific detail in many different directions. Other thing is, for instance, looking at if you single destinations like the tourist cities, how important are they? So people that come to Italy, do they go there and they stay there, or do they visit larger parts of the country? Is it longer trips? For instance, those that go to Rome, for 50% of those that, for about 50% of those that go to Rome, that's the only place that they see. So for them, Italy is equal to Rome. But not for those that go to Venice. Only for a small portion of those that go to Venice. This is the only reason for being in Italy. Usually Venice is part of a longer itinerary. So this type of information tells authorities in what way they should consider different cities to actually promote the country in a better way. If you then add places like Pompeii or Salento, which is an area, but look at Pompeii, for instance. Pompeii is not very central in any visit. So tourists that go to Pompeii, they always go to many other places, and in total Pompeii counts perhaps 10–15% of the total time spent in Italy for those that visit Pompeii. However, if you combine social media on that and how much Pompeii dictates the impression, the perception, the mood of these tourists regarding Italy, then Pompeii becomes extremely important. So it means that for those that visit Pompeii, they basically Pompeii shapes the entire perception and the entire, let's say, emotion of the visit to Italy. Let me take another one here, which is a different case. Now, if you have all these traces, you can see where people come into the country and how they leave the country. So here we're looking at Chinese and Germans, how they enter by air, land, and sea during the summer, so May to November again, into Italy. The first thing that should be surprising, there's a large number of Chinese that enter by land. So it means that they come to Germany or France, and then through train or buses, they come down to Italy, which is the first sort of surprising thing. It means that, for instance, this is part of a grand tour of Europe. It's never a single visit. But look at this one here. There's a strong asymmetry between the way the Chinese arrive in Italy and the way they depart, which means that there is an entire tour, which is a European tour, and they arrive in Europe in other countries but Italy, but frequently they leave back to their destination through Italy. This has a very strong importance for the way you promote tourism, and is done based all on telecom data and the way they enter and exit in the country. Let me show you this one, which is a totally different thing. There is a lot of attention, there's a lot of interest to find out the pattern of visits, how people move in a certain country. Now we have taken the example of Milano, and you have seen this animation that ends up into a single dot in the center of Milan. So the way it works is the following. We have taken tourists which have been seen on a certain day, which was, I think, June 20 of last year, and we rolled back time, and we actually seen where they were 2 days before. Then we go back 2 days and play time again, in such a way that you can see that all tourists that have been seen in Milan, we can see where they started from, and eventually they end up in the city. It is as if Milano would operate like a vacuum cleaner, absorbing all the tourists that go into the city. Right? Through this one, you can estimate the link between Milano and therefore also, for instance, how you can do promotion and how you can connect the various cities into an itinerary. This is a sort of a summary of that. So if you have 100 tourists in a day in Milano, then in time out where they come from. Obviously, we've done this in Italy, but it can be done anywhere where we have the same data. This is a bit controversial, but it's also important for the tourist authority. It is an animation of where tourists, international tourists, spend more money. It's a result of a model based on the telecom networks, more or less, and where that propensity takes scars and the cost, the obligation in this storage. This one here is to do with social media. We've seen so far, it is collective in the sense that we don't really know. We're just interested in the space and time they are, where they come from, and so on. Here we do one step further. For those that decide, Venice in this case, associated to the Twitter feed and translate a tweet into something which is favorable, positive. This is useful because it's an American tourist which is very active on Twitter. And we can see how and where, in this particular case, it is a tourist which is almost everywhere positive when it's close to a very, let's say, a popular tourist attraction shopping. The mood of this tourist is positive around artistic sites. It's not that positive around shopping areas. Why is this important? Because you can look at which have most influence on the social media and find out whether you impact them in a positive or negative way. So it's, I hope the animations came out well through the WebEx. And for those that want to know more, we have all this material at our site, which is collectingsensitive.org. And it captures not only the animation, but also papers and other material in this area. These are the people that have worked on this experimentation and also the sources of data. And if you want to know more, you can go back to this site. And I'll thank you very much for your attention. and I'll give it back to Sepp for questions and answers.
Okay, thank you very much for this presentation. And before we move towards the Q&A, or trying to answer a couple of questions, my apologies to everyone who had issues on and off with some of the audio. I believe to have observed those were highly correlated with the animations, so there was in some place maybe an issue with bandwidth, and apologies for the intermittent loss of audio again. With this, I would again like to encourage everyone to use the question window, the chat window, to come up with any of your comments or questions. I'm looking at the first few here. Let me just start with this one. When we go back not to the social media but to the telecom data, it is presumed that this is a research data set. When anyone wanted to set up a broader monitoring framework for continuous monitoring, what is the probability that those kinds of data sets from telecoms, from roaming observations, would be available in other countries and would be available on a continuous basis as a kind of a data product?
It's something that changes over time, but it now changes fairly rapidly. In some countries, you already have services which are based on CDRs, so the telecom traces. United States, there is a commercial service which is used by, in particular, retailers to measure as much as they can the traffic to and from a certain shopping area or just a shop. In Europe, it is still work in progress. We could get access to this data through a framework of research collaboration, and is not anything commercial, of course, at this point in time. However, it transitions into commercial work very fast. Operators have been thinking about this for many years. All the operators that I know are setting up organizations, spin-offs, many different forms to come to a commercial exploitation.
Mm-hmm. Okay, thank you. Another question is a bit more of a technical one. The title of the presentation mentions big data. Very obviously, it's big data. What is the requirement, how to manage those kinds of data volumes to come up with the condensed visualizations, aggregations, and insights you have been presenting?
So it's there's a new, let's say, there are some traditional tools which are commonly used, and I guess most of the people in this group are familiar with database, GIS, and all that, right? And there are new tools which are increasingly of common use, and I'm thinking about BigQuery of Google, which is a cloud platform for large-scale data analysis. We use Redshift of Amazon. It's a dedicated tool for handling terabytes of data. And the nice thing of these tools is that they have response times which are seconds, so you can run a query on 1 or more terabytes of data. You can get the result out more or less in real time. So you can really experiment a lot. Because most of the work that we've seen here is the result is actually, maybe we've tried 100 different analyses, and many of those actually didn't lead anywhere. Only a few of those actually led to some good, important results. And important here is, you know, in reflection of what tourist authorities in this case judge as important. So it is essential that we have tools which are fast enough so we can experiment. Now, the good news is that these tools are becoming mainstream. It's not something like, you know, a few years back they were extremely expensive, they were limited to, you know, very few players. Now they are actually very, very accessible, and as I mentioned, the one that we use regularly is Redshift, which is a standard tool of Amazon, and, and we're, you know, very, very satisfied.
Okay. Let me go on to another maybe a bit related question. I'm reading this now. Hello. a very interesting presentation. Thank you. Just a quick question. Which GS spatial analysis methods were used to predict the spatio-temporal patterns in your presentation?
We didn't use any GIS tool. Everything has been created from scratch. So these are all, well, no, let me take that back. So the first, let's say, EDA, exploratory data analysis, was based on ESRI tools, it was based on Tableau, and it was based also on querying the data sets. Once we had the perception that a certain number of analyses were interesting, then if you try to use standard GIS tools applied to this data set, usually it doesn't work. The data sets are too large, right? So we created scripts, which can be in Java, can be in Python, or sometimes can be in R, the statistical tool, just to create the specific results that we wanted. And then from there, we visualize. The visualizations here are all done by a variety of tools, like processing and Adobe tools, which are usually not the tools that we use for creating maps. They are really tools that come from the movie industry, from the game industry.
Mm-hmm. Mm-hmm. A different question is the data sets from social media. Have those be provided by the operators of the respective services, or did you use APIs to access these?
Well, everything is extracted from APIs, but we used here three sources. One is straight from Twitter, and then the other sources are CNIP, is an aggregator of multiple sources, and Topsy, which is another aggregator of data. So, so in any case, it is always through APIs, but we use more than one API. One directly from the service and two from the aggregators of social media.
Mm-hmm. A brief question is, how do you consider outliers during the analysis?
That's an interesting question. Well, we would have to contextualize the question a bit more. Statistically here we are interested into something which is a representation of the total behavior. Therefore we look more at the central points at the end, let's say call it the averages, right, instead of the outliers. The outliers are interesting to the extent to which they become segments. If it is only 1, 2, in the case of tourism, it's 1, 2, maybe 10 or 100 individuals that have very, very peculiar behaviors, well, they might be interested methodologically, but they are not interested in terms of tourism patterns. So essentially, we don't care about it. If it is an outlier, which is still a group of outliers, which have a certain size, and it has to be contextualized with a need for a certain size, then it becomes a segment, and that segment can be a very interesting piece of additional information for those that are going to look at this data. So this is just a look at outliers from the user point of view. That we can discuss about how we deal with outliers in technical terms, but I think we should be aware here that we're looking essentially at the central point of the distribution rather than the outliers.
Mm-hmm. A somewhat maybe related question is how stable or reproducible are those results? Have you looked at different time frames? So you had these annual series, but overall, is it possible to reproduce the results by and large?
So that's a very good question, because these data sets are not generically available for a long time. So we don't really have very long histories. The fact that we had 1 year of data, it is exceptional in itself, right? But that's only 1 year. So if you really want to look at, let's say, 10 years of data, well, it is just not there. However, what we do, we calibrate the results of these models against what we know from different methods. For instance, in tourism, there are official statistics which are captured by a variety of established organizations, and some of them overlap with the results of these methods. Not many things, but some of them overlap. When they overlap, we can actually calibrate one model against the other, or we can see the fitness. And that's basically what we do. Obviously, we have to wait until there is history that builds up, and then we can see whether we can capture trends which are stable over time. But at this moment, it's very hard, and it's very hard in telecom data. It's very hard with social media data. They all too new to be subject to this kind of analysis.
Another, which for now seems to be the final question. This is a bit of encouragement to everyone else who is holding back. And this is a question I'm again reading to you. It goes, research usually aims to gain better understanding of the world. Big data seems to be extremely good in predicting, but in the end it's all about correlations. Is this a paradigm shift from the why to the what?
Well, that's a long potential answer. There is an element of that, of course. So some people believe that you don't need a theory if you just have enough data and the correlations are strong enough. Then why bother finding out an explanation why things happen the way they do if you can just predict them? Amazon doesn't know why you buy a Rachmaninoff after having bought a certain book. The only thing that counts is that Amazon knows that that happens frequently enough to justify making the offer, and might be sufficient. They have no idea of the why. Actually, they don't even care about knowing the why, right? So it's totally independent. Having said all that, there is also another angle of that. So the case of Target, for instance, Target got in the news because they predicted pregnancy of a girl and sent that girl coupons, which they assumed to be relevant for the new pregnancy. But then the letter was received by the father that was not aware of the pregnancy. Obviously, that was not a good idea. So that person, got pretty angry, and Target got pretty scared that they were actually doing something which was, yes, precise from the data analytics point of view, but no, bad news from the point of view of public relations. However, what Target has done, they identified pregnancy as a particular category of people that are willing to change their purchasing patterns because they are in a specific point of their life. By targeting those, they can get better results. Now, in the case of Target, you have a theory, which is the theory of habit, why people do what they do, which is then associated to big data analytics to find out which times of personal lives do not fall in that pattern of habit, and therefore you can interfere in the case of Target by selling more goods. So you have another situation in which, yes, big data is an instrument, but it's actually used I say, simultaneously with the theory, right? And I think both things actually make sense, right? So if you have elevators and you want to find out when to service them, and you have tons of data about when they break, when they don't, well, you may or may not need to know why that happens at the level of microscopic fractures in the metals. You just need to make sure that you service them before they break. So that would be a situation which opens up tons of good use cases and tons of good applications, and we don't really care whether this is sustained by a theory. A theory might happen in the future. There are other situations in which just looking at correlations doesn't tell you anything, and the correlations may not be able to guide you in any way. And from those, you actually do need some form of more, let's say, fundamental mental model, theoretical model to make sense of that. So a few years back, people were thinking this is the end of theory, but practice actually shows that, you have these two words that seem to go on in parallel, and I guess that's going to be the case for a long time to come. But, everybody can create correlations. It's a lot harder to create theories.
Okay, thank you for this answer, and thank you for going through our list of questions we had collected throughout the session. I think we've pretty much exhausted that by now, which leaves me to thank Professor Jura-Beinert for today's presentation, for exposing us to an interesting topic, which was illustrated with data derived from most of our everyday activities, where we are maybe just not aware what this makes for all of us when we go from the individual level to the collective level. And this term of collective sensing, which is right now still on our screen and pointing us to the website of this organization, would be, I guess, the point where anyone who has further interest in this topic might go to explore and dig a little bit deeper. Thanks to everyone for the interest. Again, thanks to today's presenter for the time and effort for this presentation. Another apology for some of the audio issues we have encountered, but as you have noticed through the discussion right now, we were doing pretty well at this stage. This leaves me with the final point, the announcement of our next webinar, the next U lecture, which is scheduled for June 10th at the same time. And if we are in Central European summertime, that would be 5 p.m., but of course it's different times wherever you are right now. And this will be held by Stefan Keller from the Eastern Switzerland University of Applied Sciences on the topic of making maps from OpenStreetMap data. So June 10th, and we will announce this webinar again through the same channels we've been using now. Several thanks from the audience are pouring in right here. So thanks for organizing the seminar, and tonight's presentation would be a typical one of these. So thanks again to you, Beinat. Let me finish the session for today. And everyone, have a nice evening, have a nice day, morning, and enjoy wherever you are right now. So goodbye.